Hi, welcome to this video. So I will be teaching you some advanced techniques of integration. So we say that there are integrands that we cannot solve directly using our basic rules in integration. That's why we have here some advanced techniques of integration. So some of it are called the integration by parts. Integration by parts. So this is one of the technique. We also have integration of algebraic substitution. And also we have the what we call integration by trigonometric substitution. Trigonometric substitution. And we have also the what we call integration by rational fractions. Okay, so in this video we will be tackling or focusing our discussion in the first advanced techniques of integration, which is the integration by parts. Okay, so what is this integration by parts? Okay, so we have integration by parts. So what is this? So suppose we have two differentiable functions. So we have two differentiable functions. Say those functions we have the first function as we say u, which is in the function of x. Then the second function, let's call it a v, which is another function. Okay, so suppose we have two differentiable functions, then we can say that the derivative of this, since this is differentiable function, so we say the derivative of this u is du, and the derivative of this is let's say we have the f prime of x, so to denote to denote our function. Okay, so as well as this, so for our second function we have dv is equal to g prime of x. Okay, then using the product rule in derivative, so the derivative of these two functions, using product rule is that we have if we take the product of our two functions, so we have function 1 and function 2, so the derivative of this is what again? Using the product rule, we have first, which is our fx, times the derivative of the second, which is g prime of x, right? Then what? Plus the second times the derivative of first is f prime of x, right? Okay, so that is according to our product rule. Then if we have this as our answer for the derivative, then if we take the antiderivative of this, then our answer of course is this one, right? Because the derivative is the opposite of that, is the antiderivative, which is the integration. So if we integrate this one, if we integrate the f of x, g prime of x plus g of x f prime of x. So if we integrate this one, then our answer of course is this, f of x g of x, right? So from here we can write this as the integral of fx g prime of x dx plus the integral of gx f prime of x dx, right? So we have f of x g x, okay? So the integral of this one is this, right? So from that, can now say that we can now say that after we establish this, it's also true that by using the algebra, it's also true that this produces this formula. This produces the formula, which is the integral of this term, the integral of fx g prime of x dx is equal to this one, f of x g of x minus the integral of gx f prime of x dx, right? So we only do the algebra here. So in order for us to find the value of this this term here, so this is the integrand, our integrand. So we have fx g of x dx, and from this formula that we established, or this equation that we established, we do the algebra by having this term, and then we move this the other side to the other side to the other side. That's why it became negative. Okay, so plus this term, okay, minus this term. Okay, so after integrating this formula, this is the basis of what we called our integration by parts. Okay, so we can also rewrite this using our designated letters. Wherein our f of x is just u and our g of x is just v, to simplify our formula. So we have the integral of f of x is our u, and g prime of x is our, of course, dv, the derivative of our v. Okay, so u dv is equal to f of x, g of x. We have u v minus integral of g of x is v, then f prime of x is du, right? So we have the integral. If we have this problem, we have u dv, then our answer can be expressed in u v minus integral of v du, and this is what we call the technique, which is called integration by parts. Okay, so in this integration by parts, so this technique, let's rewrite this. We have u dv and u v minus integral of v du. So we box this one. Okay, so there are few notes that we must remember if we have this kind of problem. Okay, so first thing is that there is no specific rule in choosing which is u and which is v. So we have no established rule which is v and which is u. Okay, as well as the u and dv, as well as dv and du. Okay, so but there are suggestions that it is suggested that the dv must be integrable. Okay, so we must remember that if we will choose our dv later on when we do the computation, it must be integrable. Okay, so do not choose dv that you cannot integrate. Okay, so remember that the dv must be integrable. And also when we look here, we have the VDU, right? So another suggestion is that the VDU rather, must not be more complex than our UDV. Okay, because if this is more complex, then we will have a problem integrating this later on, right? So that our technique is just that the VDU must be not be more complex, or it must be simpler, and it must be integrable. Okay, so must not be more complex, must not be more complex than UDV, than this one. Okay, so the VDU once again must not be more complex than our original integrand. Okay, so another one is that this integration by parts is usually used when we have an integrand that has usually used when integrand has usually if the integrand has logarithms, usually if there's an inverse trigonometric functions, also products and its products. Okay, so once again, let's review. So we have integration techniques, since there are problems that cannot be solved directly using our basic formulas or basic rules. We have the integration by parts, integration of algebraic substitution, trigonometric substitution, and by rational fractions. So for this specific video, we will we discuss the integration by parts. So we say that the integration by parts came from here. Since suppose we have two differentiable functions, u and v, and then they are two functions of fx, functions of x, and g of x. So we say that the derivative of this is the prime of x and prime of g prime of x, which is we equate this as du and dv. And then we say that the derivative of these two functions using the product rule, the function 1 and function 2, is that this first times the derivative of the second plus the second times the derivative of the first. Then from that equation, we all know that if we integrate this, we will go back on our original function product. Okay, so after knowing and establishing that equation, we further get the formula, which is we equate the fx g prime of x dx into our integrated functions. So we come up with this one, and then we change this function in terms of letters that we left. Okay, so we have u, and then dv is equal to, we have uv minus integral of v du, and that is the technique of the integration by parts. Okay, because we integrate this part by part. Okay, so since we come up with this final equation, which is called the integration by parts, then we have some suggestions and notes here. So first is that when we are choosing our variables, which is u, which is du, which is v and dv, then there are no rule when we are choosing which one. Okay, but some have suggestions in choosing. First, that dv must be integrable. Okay, and the v du, this part here, must not be more complex than the udv, because later on we need to integrate also this one. That's why it must be more simpler, and it must not be more complex than our original integrand. Okay, and usually this integration by parts techniques can be used, or usually used, when we have the integrand which is in terms of logarithms, inverse trigonometric functions, and its products. Okay, so in the next video we will be having some problem regarding this integration by parts. Okay.